program is brought to you by Agnes Scott College. For more information about Agnes Scott College, please visit our website at agnesscott.edu.
Before we begin, I would like to thank everyone for coming out and, of course, Dr. Depree for speaking tonight. As a reminder, this is a for-donation event. So if you thought the event was good, funny, and maybe insightful, please do not hesitate to help our hosts on the way out. With that, I would like to introduce Dr. Christopher Depree, Professor of Physics and Astronomy at Agnes Scott and Director of the on-campus Bradley Observatory. He was born in Hong Kong and has lived in many places, including Manhattan, San Francisco, and Saudi Arabia. Dr. Depree majored in physics as an undergraduate at Duke University and then moved nearby Chapel Hill, North Carolina, to get his PhD in physics at the University of North Carolina. As a graduate student, he lived in Socorro, New Mexico, and worked at the Very Large Array, or the VLA. Operated by the National Radio Astronomy Observatory, the VLA is one of the world's largest radio telescopes and has been featured in many films, most famously Contact. Dr. Depree studies how massive stars form using telescopes like the Very Large Array, the Hubble Space Telescope, and the Spitzer Telescope. He has written numerous articles on the topic in the Astrophysical Journal and is co-author of The Complete Idiot's Guide to Astronomy, which might be a good thing for a few members in the audience. Recent Advances in Issues in Astronomy, and author of Physics Made Simple. In addition to conducting research, Dr. Depree is an advocate of astronomy for everyone. He hosts a monthly open house at Bradley Observatory, bringing together students, faculty, area residents, and members of the Atlanta Astronomy Club for lectures, planetarium shows, concerts, and viewing with the observatory telescopes. He lives in Decatur with his wife, his 4 kids, 2 dogs, 2 cats, and innumerable fish. Please join me in welcoming Dr. Depree.
For that kind introduction, and thank you to the sophomore class at Agnes Scott for the invitation to speak to you. Can you all hear me all right? Yeah. All right. I'm speaking from notes, which is not how I usually lecture, but you know, when you're invited to give a last lecture, you got to take it seriously. When Rachel Berger first asked me last fall to deliver a last lecture, it sounded a bit ominous. If I were able to deliver only one last lecture to my students, what would I talk about? Did she know something I didn't know? Was I going to deliver my last lecture this spring, tonight, perhaps? In the case of Randy Pausch, of course, it was not just an intellectual exercise. He had been diagnosed with pancreatic cancer and did not have long to live. But the request from the sophomore class to give a last lecture has been a real gift. Since the request was made, I've been thinking about it in the back of my mind almost constantly. And I immediately started to feel the curious and fascinating challenge of this lecture. What would I talk about if I could only talk about one topic, or at least had only about an hour to talk about several related topics? What would I want to tell my students if I had only one last chance? I finally decided it was too overwhelming, so I'm going to show you a video tonight. Actually, I've decided to try and tell you something from my mind and from my heart about this planet, and why I think it is important that humans do everything we can to not only maintain planet Earth, but to leave it better than when we arrived. In the months since Rachel asked me to talk, I've thought often about what I would say But even from the beginning, there was a word that kept coming into my mind, uninvited. It was one of those insistent thoughts that would not go away. I know that in religious circles it's sometimes referred to as a call. I felt a call to talk about stewardship. I want to talk to you tonight about the stewardship of planet Earth. Now, stewardship may not sound like a very interesting word at first blush. The etymology of the word tells us that it comes from the Old English keeper of the hall. But in all of the many definitions of steward and stewardship, there's a common thread. It means someone who manages or takes care of something that belongs to others. If we are stewards, then the thing that we are taking care of is not our own. If we are to be stewards of the earth, then we must admit that the earth is not our own, but that we are simply looking after it while we are here. And if the history of life on this planet is any guide, we will not be here forever. Many different living things have been ascendant on the surface of the earth. We are ascendant now, but will most likely not be forever. Others will inherit the earth. We are taking care of the earth for others, for our descendants, who have every right to inherit an earth as good or better than the earth that we inherited. I'm an astronomer, and I want to tell you from my perspective why I think that talking to you about stewardship of the earth is the most important thing that I could possibly do, and why I think that the earth and humans are rare enough to do everything in our power to do no harm to this planet. Let me start with the story. It's a story that began, as best as we can tell, about 13.7 billion years ago. At that moment, all of the matter and energy in the universe came into being, and the universe began an expansion that is still continuing to this day. In the beginning, it was too hot and dense for anything to form into matter that we would recognize today. Matter and energy flowed back and forth into one another through a process called annihilation, through processes called annihilation and pair production. Photons would come together, photons of light would come together to form pairs of matter and antimatter, and that same matter and antimatter would come together or annihilate and form pairs of photons. At this early time in the history of the universe, matter and energy easily flowed back and forth into one another. As the universe cooled, eventually the photons didn't have enough energy to create matter and antimatter when they came together. There was not enough energy in them to create particles. At this point, there was a great wave of annihilation, as most of the matter and antimatter in the universe became photons of light. Protons and antiprotons, electrons and anti-electrons, all swept up in a tide of light. If the universe had been exactly balanced in matter and antimatter, then all matter would have been annihilated at this early moment in the history of the universe, leaving behind nothing but light. Photons of light would have moved into the expanding universe, stretching out and cooling with time and becoming less and less energetic. But there would have been no matter, no hydrogen and helium, no atoms or molecules, no stars, no galaxies, just light. Certainly the universe would have been a more tidy place if this had happened. Pure light, no messiness at all, very little complication, no volcanoes, no nuclear fusion, no viruses or bacteria, no disease, no heartbreak, no sadness, no war, just an ever-expanding universe of light, pure and simple, but inherently incapable of building an observer, of making anything like us. But that is not what happened. There was a tiny amount, about 1 part in a billion, of an excess of matter over antimatter. After the great wave of annihilation that turned most of the matter and antimatter into in the universe into photons of light, 1 part in a billion remained. And it is that 1 part in a billion that we see as the universe. Both the matter that is visible and what we call dark matter. It is that 1 part in a billion that became the stars and galaxies, the planets and moons, the atoms and molecules, the oceans, and animals and people, the pages in our books, the stone in our sculptures, the electrons and blood cells that flow through our brains and our veins, the eyes that allow us to look out into the universe and see where we came from. And thank goodness for that little bit of leftover matter. For all its messiness, the universe has been a much more interesting place for the past 13.7 billion years, thanks to that 1 part in a billion of stuff left on the kitchen counter of the universe. As the universe continued to cool, the matter that was left, bare protons or hydrogen nuclei, formed a little bit of helium in a process referred to as primordial fusion. One amazing thing about this early time in history is that the universe was so hot that the entire universe was very briefly at the temperature of the interior of a star, tens of millions of degrees. There was no empty space like there is now. There were no vast stretches of nothingness. Early on, the entire universe was a vast nuclear furnace turning hydrogen into helium for a brief moment. And that was the first 3 to 4 minutes of the universe. This is an extremely long talk, by the way. But the universe wasn't done. It continued to expand and cool rapidly, and the brief process of primordial fusion came to an end. Eventually, after a few 100,000 years, the universe was cool enough for the positive protons to hold on to the negative electrons, and for them to form the first neutral hydrogen atoms. When this happened, the light in the universe, that same light that was released when most of the matter and antimatter annihilated, was able to get out and move across the vastness of space. It was as if a fog had cleared. A fog of electrons that had bound up the light of the universe cleared, and these photons that escaped when the electrons and protons came together for the first time are the photons that we see in what is called the cosmic microwave background. This image, made by an orbiting microwave satellite called the Wilkinson Microwave Anisotropy Probe, or WMAP, provides very strong evidence that the universe did have a beginning, that the universe has not always existed, and that there was an origin to the universe in time. And what we are seeing in this image is a remnant, an echo of that fiery beginning. From humble beginnings, from a sea of hydrogen atoms with tiny temperature variations, the universe assembled everything we can see through telescopes today. The image shows the tiny, about 1 part in a million, the tiny fluctuations in the temperature of the early universe. Fluctuations that indicated the universe again had some interesting imperfections. If all matter in the universe had been perfectly distributed, then matter would have never collapsed via gravity to form stars and galaxy clusters. The universe would have been perfectly smooth. But that is not what happened. There were variations in the distribution of matter in the early universe, and the matter that was left, that 1 part in a billion, started to feel the tug of gravity. Gradually, over the intervening 13 billion years, the universe continued to cool, and gravity pulled this matter into vast structures that we call stars, and collections of stars called galaxies. Collections of galaxies called clusters, collections of clusters called superclusters. I think they're even super-duper clusters. Along with these galaxies, the first generations of stars formed, again via the force of gravity, lived their lives, and exploded, enriching the regions between the stars with the products of nuclear fusion. The hydrogen and helium formed in the first few minutes of the universe were joined by the carbon, oxygen, nitrogen formed in the cores of stars. And when large stars blew up, they provided the energy required to make things like nickel and magnesium and gold and silver. Later generations of stars formed, enriched with the remnants of their ancestor stars. The formation of these later stars was often accompanied by planets, and on at least one of these planets, complex molecular reactions led to the formation of information-bearing molecules that we call DNA. And through the process of natural selection, the land, skies, and oceans of planet Earth filled with an amazing variety of living things, of living beings that could swim and fly and run and think and wonder and build tools, one of which they called telescopes, capable of looking back through space and time to the beginning of the universe. We should be good stewards of this planet because it took a long time to get here. Only in the past 50 years of that 13.7 billion years have we started to understand just how long it has taken. Now I want to turn to this planet on which we live. A planet that from time to time can seem oblivious to our presence or even hostile to it. Just a few years ago, an enormous tsunami swept across Southeast Asia, killing over 200,000 people. I remember clearly that when my daughter Madeline, who was just 6 at the time, heard the news, she said that she was mad at God. I thought about her reaction for a long time. I was happy that her belief in a God was so secure that she had someone to blame, but I had no good answer for her as to why God would let this happen. In the years since then, I had occasionally returned to this thought and had not come up with any good answers. Her question is an old one, of course. It's a question of theodicy, as I learned in my team teaching last fall with Mark Douglas of Columbia Seminary. How can evil and suffering exist in a world with God? The tsunami that killed over 200,000 people was attributed to a sudden subduction of an oceanic plate located between India and Indonesia. 50 years ago, the existence of plate tectonics, the motions of vast pieces of the Earth's surface, was not widely accepted. Now, of course, plate tectonics are an accepted part of our planet's routine. In fact, plate tectonics may be one of the ways in which our planet is rare. We know of other planets without plate tectonics. Venus does not appear to have plates that move, although it is covered in volcanism. It periodically melts its entire surface. Mars doesn't have plate tectonics either. Venus is geologically active, covered in volcanoes, while Mars is geologically dying, if not already dead. But our planet has plates that move, and those tectonic motions are apparently an important factor in the presence of life on the planet. The Earth's oceans also may play an important role, and together, the oceans and the subduction of plates are an important way that planet Earth recycles carbon dioxide from the Earth's atmosphere into its interior, keeping the surface of the Earth from becoming too hot. The way it works, very briefly, is this. Carbon dioxide in the Earth's atmosphere naturally dissolves into the Earth's oceans. Some of this dissolved carbon dioxide stays in solution, and some gets built into structures on the seafloor, like coral reefs, by sea creatures and locked into calcium carbonate. This calcium carbonate then rides its way along the seafloor plates and gets subducted into the Earth's interior. The Earth's surface can remain habitable and not unbearably hot only because its plates move around. If one of these plates is located under the Earth's oceans and moves suddenly, it can create tsunamis. So the quandary is similar to the one described at the beginning of the universe. We might have had a perfect universe inhabited only by light. We could have also had a geologically dead planet like Mars. On this planet, there would be no death by tsunami because there would be no tsunamis and there would be no living things. So perhaps it comes down to this question. Is some life however tenuous and painful, better than no life. Certainly the absence of life would avoid all of its problems, but it would also avoid all of its beauties. If you're a religious person, you could say that there is a creator who has chosen life over the absence of life, who has chosen for there to be something rather than nothing. If you're not a religious person, you can think about the same questions, but you don't have to attribute it to a creator. There are other ways in which the earth might be rare in hosting life like us. Many of them are outlined in a fascinating book by Peter Ward and Donald Brownlee entitled Rare Earth. In this book, they make the case that phenomena like plate tectonics and oceans and the presence of a relatively large moon are essential to the existence of life on this planet. And the fact that we have all of these could mean that our planet is not as common as we once thought. Our moon may not seem so unusual. After all, we only have one moon, and planets like Jupiter and Saturn have many more, 20, 30 if you count the small ones, some of which may be covered in ice, and underneath that ice, water. Other moons like Titan have methane oceans. But the surprising thing about our moon is that relative to the Earth, it's huge. If you were to build a scale model of the Earth-Moon system, and my students will remember this analogy, I hope, and your head was the Earth, then the moon would be a tennis ball about 30 feet away. The other terrestrial planets, Mercury, Venus, and Mars, either have no moons or have moons that resemble asteroids. They look like potatoes, more than objects like our moon. The outer planets, Jupiter, Saturn, Uranus, and Neptune, have many, many moons, but they're far larger planets, so it's less surprising that they have these moons. Something very unusual happened early in the history of the solar system that gave us our unique moon. We have the moon that we do because of a chance encounter between the early Earth and a planetesimal. Anything with esimal sounds small for something that big. But the planetesimal was perhaps the size of planet Mars. The collision was violent enough to rip off one side of the entire planet, and the orbiting debris of this collision finally coalesced via gravity to form the moon. When the moon first formed, it was much closer to Earth than it is now, with the debris of the collision forming the moon at a distance of about 3 to 5 times the Earth's radius. That would put the moon about 15 to 20 times closer than it is now. Now, if you think of the moon on the night sky, if you hold your hand out at arm's distance, the moon's about the size of your pinky fingernail, smaller than you might think. But if the moon were 15 to 20 times closer than it is now, it would have been 8 to 10 degrees across the sky. That's more like the width of your hand. Imagine a moon 20 times bigger than it is now. Now, you're probably aware that the moon's gravity is the force that causes ocean tides. And since the moon and Earth were much closer in the early history of the planet, tides would have been much larger, causing the Earth's oceans to range widely over the surface of the Earth, stirring molecules and water together like a huge test tube. The presence of the moon has also created a far more stable climate than we would have had without it. The moon acts like a gyroscope, stabilizing the tilt of the Earth's axis, so that while we do have seasons, they are regular and stay regular for long periods of time. Planets like Mars that do not have the stabilizing presence of a large moon apparently have axes that tip and move through large angles, resulting in much less stable atmospheres. Even in our own solar system, there are no environments in which human life could exist without some pretty thick suits and helmets. Our bodies have evolved on this planet and are perfectly suited to it. We are not well suited to survive anywhere else. Another way to state this is that in a broader sense, if the universe were not exactly the way it is, then we would not be here to observe it. If the universal constants like the mass of an electron or the ratio of the mass of an electron to its charge or the strength of the gravitational force were not exactly what they are, then we could not be here to observe the universe. This idea and ones related to it have been called the anthropic principle. The fine-tuning of our universe and its constants is widely accepted, but this idea has been used to go farther, to make arguments in two directions. One is that the universe and everything in it are exactly the way they are because they were designed by a creator to be that way. The universe was made so that it could eventually make observers, make things like us. The other idea is that the universe is the way it is because there are an infinite number of universes, many of which could not create life. For example, universes in which only pure light would exist, or there would not be enough matter to create stars and galaxies. All of those universes are inherently unobservable to us and utterly incapable of creating an observer. We are here to observe this universe that is suited to our existence because it is one of a multitude of universes, most of which didn't work out. With the current state of our understanding, we can pick between a creator and an infinity of unobservable universes. So I'll leave that choice to you. Human beings are probably not the only living things in the universe capable of contemplating our origins. But we are the only ones that we know about right now, and we've looked pretty hard to see if we have company. At last count, we've detected over 300 planets in orbit around nearby stars. Most of them could never be home to life like the life that inhabits Earth. They're either too close to their host star or too far away. They would be too hot or too cold. We haven't always known this, of course. This understanding of the scale and variety and processes in the universe are the result of several thousand years of careful observation and thought. Since ancient times, humans have looked up into the night sky and noticed that there were objects that were essentially fixed, the stars, objects that looked like stars but moved, the planets, and larger objects that moved through the day and nighttime sky, the sun and the moon. These 7 objects visible to the naked eye that move relative to the stars give us the names of our 7 days of the week, at least in French and Spanish. And the details of their motion took several thousand years to figure out. Now, exactly 400 years ago, in 1609, several astronomers made progress on different fronts, improving our understanding of our place in the universe. In this year, Galileo made use of the first telescope, and Kepler published his work on the elliptical orbits of the planets. Starting in the middle of the 16th century, astronomers like Copernicus were considering the idea that the Earth was not at the center of the solar system, but that it might orbit the sun along with all the other planets. In the 400 years since the first telescope was used to observe Jupiter and the moon and the stars of the Milky Way, humans have made great strides in understanding the information coming at us at a variety of wavelengths from all over the universe. Humans first concentrated on building ever larger and more sensitive optical telescopes. They increased in size and complexity through the next several hundred years, culminating in telescopes like the Hale 200-inch, that's the size of its primary mirror, the 200-inch telescope at Mount Palomar, dedicated in the early part of the 20th century. The pinnacle of ground-based optical observing can be found in telescopes like the Keck 1 and Keck 2 telescopes at the summit of Mauna Kea in Hawaii. And humans did not stop there. We've used the same technology required to launch intercontinental ballistic missiles at our enemies to launch orbiting telescopes into space. Now familiar sounding telescopes like the Hubble bring crystal clear images from their perches orbiting our planet. We inherited the moon. The collision with the moon is the hand we were dealt. But we have added to the moon a host of orbiting objects that bring us information about the universe around us. Some of the satellites look out into space and others are used to look back at the Earth, to monitor scales far too large for us to see from the surface of the Earth, and to let us know how we're doing in our stewardship of this planet. The truth is, we're not doing so well. In 2006, the Los Angeles Times presented an investigative series about the condition of the Earth's oceans, a series that eventually won the Pulitzer Prize. In the series, the authors reported on large regions of the ocean formerly known as gyres, where huge amounts of ocean trash, mostly plastic, accumulate. This plastic trash rides ocean currents from the west coast of the United States and from Asia and collects at 2 points, one off the coast of California and the other just south of Japan. The gyre off the coast of California is approximately twice the size of Texas. If you've ever driven across Texas, you can appreciate just how large that is. In this part of the ocean, studies carried out recently by Charles Moore, a marine researcher, have shown that for every pound of plankton, there are 6 pounds of plastic. That is a fact that gets us closer to the truth that we are not being good stewards of this planet. Much of this plastic material finds its way to the beaches of certain parts of Hawaii, Hilo in particular. This is an image of one of the beaches in Hilo, Hawaii. Hilo is the name of the city that astronomers fly to when they are planning to observe at Mauna Kea, the summit where the Keck telescope and others are located. To me, it is amazing that these two symbols of what humans have accomplished, for good and for bad, have come together in the same place. How can the same humans who have marshaled their resources so successfully to study the heavens have neglected what they are doing to the oceans of their own planet, with piles of plastic washing up on the beaches of the islands from which they observe the heavens? I'm not in any way saying that we shouldn't be doing astronomy. We should, and we must. I think it is one of the most fantastic things that humans do. It shows what we are capable of, and it is what I have devoted my professional life to. But we need to devote the same level of energy and persistence to solving the problems around us, the rising tide of plastic trash that is incredibly starting to dominate regions of the Pacific Ocean. So how does all this relate to stewardship? And why am I telling you all these other bits of information about the universe? We are all together on this planet at a time when our actions will have profound influence on the humans or other living things that come after us. This image was taken by the astronauts on Apollo 8, which is the first mission to bring astronauts to orbit around the moon. They were supposed to be photographing the lunar surface, but as they emerged around the limb of the moon, they saw what's now called Earthrise. As one of the astronauts described it, all 3 of them forgot about the lunar surface and started taking pictures of the Earth. The view of our planet from space, without any political or religious boundaries, was an inspirational sight and an important rallying image for the young environmental movement. Seeing our planet as it really is, beautiful, full of life, but also very alone and small in the vast emptiness around it, made highly trained professional astronauts forget their duties and inspired awe. This moment may have been the most important outcome of the Apollo missions. What is the most amazing thing to me is not so much that the universe came into being. The existence of stars and planets are the result of fairly simple rules of gravity and electromagnetic forces and nuclear fusion. What is at least as shocking, and perhaps even more so, is that the minds that we take for granted most of the time developed from the starting point of a sea of matter and energy. Consciousness and minds that have developed to the point that we can not only ponder questions about our place in the universe, but perhaps understand the origin of our universe and extend our minds back over billions of years to the moment when it came into being. The fact that we have language to communicate this understanding to others, to argue and think about the origin of the universe and the origin of ourselves. And these same minds, these minds that can wonder about the origins from simple hydrogen atoms to all of the complexity that we see around us in the universe, these same minds are full of desires and needs for material comfort that have driven us to create many things, both good and bad, for our planet. As I often tell my students in astronomy classes and first-year seminars, humans would have a hard time destroying planet Earth. As fragile as our planet might appear from space, the Earth is incredibly resilient. And specific life forms aside, life in general will probably continue to thrive on Earth, with or without humans. Alan Weissman's fascinating book, The World Without Us, explores this possibility. What would the Earth be like if humans were suddenly whisked away? According to the book, the Earth would only take a few hundred years to erase most signs of us. Our most long-lived contribution to the Earth, sadly, would be the pollutants that we are now creating in the form of plastics and nuclear waste. Those signatures would be around much longer than our most precious intellectual and artistic achievements. The glaciers of a coming ice age in the next few thousand years would erase most of the remaining signs of us that survived even that long. There have already been several wholesale changes in the dominant life form on our planet. So while we do appear to have the power to make the Earth uninhabitable for humans, it would be very difficult for us to destroy the planet. But since we understand what is at stake, since we have these minds that have shown us what we are currently doing to the planet, shouldn't we do everything we can to keep the Earth not only habitable, but a place where humans, with all of their faults and all of their beauty, can thrive? While in a universal sense, our technology may be in its infancy, we are already able to accomplish amazing things. We have sent humans to the surface of the moon to look back at the Earth in awe. And we have sent robotic probes out so far that they've actually left the solar system. We have created music and art and literature that represent the depths and the heights of our minds. Being that we can do all these things, shouldn't we use our considerable abilities to be true and good stewards of this planet? That means taking care of the Earth, not primarily for ourselves, but for others. Who are the others? They may be our descendants. They may be other life forms that will follow us on this planet. They may be some living things in the far distant future that we can scarcely imagine, who will look back on us and say they were good and faithful stewards. They may look nothing like us, but if they have minds, they will be living things in our image. Perhaps they will have language and doubt and curiosity and all of those things that make humans interesting. They will not inhabit a universe full of perfect light. They will inhabit the same messy, matter-filled universe that we do. But they will be grateful, if they inhabit the Earth, that we did what we could to allow the Earth to follow its natural rhythms, that we did not load the oceans with so many pollutants that we killed ourselves off, that we did not pollute the skies with gases that ended up doing us in. That is what happened to most of the first anaerobic bacteria on Earth, about 2.5 billion years ago. When the Earth was still relatively young, evolving organisms called cyanobacteria started to give off oxygen as a byproduct of oxyphotosynthesis, generating atomic oxygen. This oxygen combined with iron in the Earth's oceans, creating iron oxide, rust, and you can actually see the rust striations in rocks from this period. The oxygen finally found its way into the Earth's atmosphere. This molecular oxygen created a hostile atmosphere for the early Earth's anaerobic bacteria, causing the Earth's atmosphere to cool as well, with global temperatures plummeting. Anaerobic bacteria died out as the dominant life form in the transformed atmosphere, full of molecular oxygen, became a source of life to the ever more complicated life forms that followed. As it turns out, one life form's toxic substance is another life form's life-giving gas. But surely we're something different than bacteria. We know what we are doing. We are experiencing the changes that we are bringing upon the earth. Surely we will not stand or float by and allow the earth to become a place where we can no longer live. I started with a quote from Randy Pausch. We cannot change the cards we are dealt, just how we play the hand. I recently assigned a homework problem in which my class had to calculate how many 5-card hands there are in a 52-card deck. It's a pretty straightforward problem in probability. It turns out there are about 2.6 million hands. You remember that one. I then asked them to calculate the probability of a royal flush. 10, jack, queen, king, ace, all the same suit. There are 4 possible royal flushes and 2.6 million hands. So the chance of being dealt a royal flush is about 1 in a million. We have been dealt a royal flush in planet Earth. Whatever else is out there in the universe, we know what is here. It is rare and it is worth preserving. We humans are fortunate. We actually know what we need to do to turn around the disastrous changes that we see starting to happen. We know that we need to reduce carbon dioxide emissions. We know that we need to stop overfishing and polluting the oceans. We know that fission reactions create radioactive materials that we still do not have a good way to dispose of. All of the problems are arrayed before us, and we sit here, 6 billion of us, with these amazing minds, brains capable of stretching through time, backward and forward over billions of years, to contemplate the origin and eventual fate of the universe. And yet we have not yet agreed as a planet to reduce greenhouse gas emission. It would be sad to have evolution produce creatures with such an enormous capacity to create and appreciate beauty that would at the same time watch it all slip away, for them and for their descendants. That is not good stewardship. What can we do? Here are some ideas. Work like crazy to get our nation to reduce its emission of greenhouse gases. This is something that will require wrenching changes. Individual changes can reduce our overall appetite for power, for electrical power, but changes at a national and international level have to be made to change the way that power is produced. We have the technology to produce most, if not all, of our power from renewable, non-fossil fuel sources. Change can come very rapidly when governments and people take action. Take, for example, the recent plastic bag levy in Ireland. The government of Ireland assessed a 15-cent per bag tax on plastic bags. The revenues from this tax were earmarked for environmental improvement. This had a drastic and rapid twofold effect. Use of plastic bags, previously 1.2 billion bags per year had been used in Ireland, billion. Use of plastic bags dropped by 90%, and the bags that were still used, the remaining 10%, raised revenue for environmental work. Other governments have taken similar steps. The government of Bangladesh has outlawed their use. The particulars of how to reduce the use of plastics that can often end up as environmental waste can be left up to each government, but the results can be dramatic and rapid. The governments of China and Australia have started to end the use of plastic bags in those countries through the imposition of similar plastic bag levies. We need to push our legislators at the state and federal level to follow the lead of countries like Ireland, China, Bangladesh, and Australia. The only losers in this scenario are the manufacturers of plastic bags, and they will complain. But there are many more of us than there are of them. Here's another thing we can do. Wind power has the potential to provide 20 to 25% of the power used in the United States. Regions in Denmark and Germany already draw between 25, some regions up to 100% occasionally, of their power from wind resources. This is not an artist's conception. This is an installation off the coast of Denmark. Currently, the U.S. draws less than 1% of its power from wind resources. We aren't even close to realizing our potential for this renewable, clean resource. And in terms of global energy use, the U.S. Department of Energy estimated that the world's winds could theoretically supply more than 15 times the current world energy demand. Wind alone. Moving quickly toward this goal would provide cheap, clean energy, not only to our own country, but to developing nations of the world. Find out what your power company is doing to rapidly increase the use of renewable clean energy. In California, electric utilities are required to produce 20% of their electricity from renewable resources by 2017. What if this was made a national priority? What if such a requirement was supported by federal research funds? We know what we need to do. We have the technology and the intelligence to do it. And examples from across the globe have shown us that change can come remarkably fast if it is required of us. The universe has made us in its image. We are the material descendants of those first hydrogen nuclei that held on to electrons and started a long march through billions of years to the current day. Some of those hydrogen atoms are in you. And as unlikely as it is, here we are, a tiny part of the universe that has become conscious of itself. When we study the universe, we are studying ourselves and our humble origins. We are made of the stuff of the universe. 13.7 billion years of galactic and stellar evolution has led to a universe in which, and a planet on which, we can exist and indeed thrive. That is a wonderful thing. Whatever else is out there in the vastness of space, we know this: humans are precious. We should work to preserve ourselves and our descendants and this tiny bit of consciousness that has arrived in the universe. There may very well be other consciousness out there. There may be other parts of the universe that have emerged from the haze of protons and electrons and taken on conscious physical form. But if they are, we can't do anything for them. We are not stewards of their planets. We are stewards only of our own. Our planet is full of life. But as far as we know, we are the only living things on this planet with the ability to consider our place in the universe. We may not be the last living things on our planet that will have an opportunity to understand the earth and its processes, but we probably are the first, and that is special and noteworthy. The earth is precious. We should protect it and all living things, not because it needs our protection, but because we know better. The earth is tough. It will survive with or without us. But if we are to be good stewards of the planet, we should take care of it for those who are to follow us. That will be our legacy. Stuart Brand, in his book, How Buildings Learn, tells one of my favorite stories about stewardship. I will end by telling it to you in his own words. You may remember this image. New College was founded in the late 14th century. It had, like other colleges at Oxford, a great dining hall with oak beams across the top. These might be 2 feet square, 40 feet long. A century ago, some busy entomologist poked at the beams and discovered that they were full of beetles. This was reported to the college council, who met in some dismay, because where would they find beams of that caliber nowadays? One of the junior fellows stuck his neck out and suggested that there might be some oak on the college land, so they called the college forester, who of course had not been near the college for years, and they asked him about oak. He pulled his forelock and said, "Well, sirs, we was wondering when you'd be asking." On further inquiry, it was discovered that when the college was founded, a grove of oak trees had been planted to replace the beams in the college when they became beetly, because oak beams always become beetly in the end. This plan had been passed down from one forester to the next for 500 years. We don't cut them oaks, them's for the college hall. It's a nice story, That's the way to run a culture. I love this story. It's a story of good stewardship, of thinking about those who will come after us and what they might need. To me, this story shows that humans are more than capable of being good stewards, of looking forward in time, not just to our children and grandchildren, but to a time when humans may no longer inhabit the earth. Given all that we know and what we have come to appreciate about the uniqueness of the earth and its environment, surely we should not be remembered as the ones who threw it away. Let us be like that architect long ago who knew what problems his creation might face and thought ahead of providing a way out. He knew that type of wood would get beetles. Those were the cards he was dealt. But what did he decide to do? He decided to plant some trees. Trees that would be there hundreds of years in the future when they were needed. That is the hand he played, and we are the beneficiaries. We know many of the problems that the earth will face in the coming decades and the coming century. We have them arrayed before us. We have the intelligence to solve them. What trees will we plant to make sure that we have been good stewards? How will we play our hand? That is up to us. Thank you. And I can't see, oh, there we go. I'm more than happy to answer any questions if you have them. Yeah, Locke?
So, are we anywhere at all close to having fusion as reaction for energy?
Fusion is really difficult. Well, controlled fusion, right? We have fusion reactions, but unfortunately they're hydrogen bombs, and we don't like those. But a controlled fusion reaction is difficult because a plasma wants to escape. And there have been experiments going on for decades at Princeton and other places where they try to contain plasma in a magnetic field. But they've never had sustained fusion reactions. So I think it's still a long way off. Fusion reactions are an incredible potential source of energy because, like the universe uses it all the time in stars. It's a great source of energy. But they're a lot bigger and, they have space to do those things in their cores. But if we can ever figure that out, yeah, it'll be an incredible source of energy. Any other questions? Yeah, hey, Rachel.
Did New College Oxford plant more oaks?
Everyone always asks that question, and I don't know the answer, but I certainly hope the answer is yes. Yeah, you would hope so. What a terrible story if they were like, no, we put a parking lot. There's a Walmart there now, actually. Well, I really appreciate you all coming out tonight. If you are shy to ask a question, please feel free to come up and ask any other questions you have. So thanks again very much.